In this segment, we will be looking at two more math functions. The operations that these functions are related to are frequently used in engineering and science disciplines, and they are called the cross product and dot product. We first explain the dot product. The MATLAB provides the function dot for computing the dot product. This function needs two vectors. A vector in MATLAB is represented by a matrix containing one row or one column. So let us assume we have a vector C containing these three values, and we have another vector which also contains three values. So now the dot product is going to compute the element-wise product of these two vectors, which in this case is going to be 4 into 5, 5 into 5, and so on. And then finally it is going to add all the products together. So this is the corresponding result, which in this case is 75. The other way of doing the same is that, remember we covered how to compute the element-wise product like this. So this is going to multiply the corresponding elements. And finally we can compute the sum of this element-wise multiplication. And it will give us the corresponding result. If the inputs are not vectors but they are matrices instead, so let's say we have matrix A, and then we have another matrix that is matrix B, and then when we pass these two matrices to the dot function, so it is going to compute it based on the corresponding columns. This means that the elements in the first column of matrix A are being multiplied by the elements in the first column of matrix B. Similarly, the elements in the second column of matrix A are being multiplied by the elements in the second column of matrix B, and the same applies to the third column of the two matrices. If we want to perform the dot products of the two matrices based on the rows, so we can mention an additional argument of 2 over here. Remember, the default value of this argument is 1, which means that if you do not specify it over here, then the default value will be 1. And in that case, the operation is being carried out on the columns. So now this is the result, and it represents the dot product of the rows of the two matrices. And we can verify that easily by inspecting the values. 1 into 9, and then 2 into 8, which is 16, so 9 plus 16 is 25, and finally 3 into 7 is 21, so 25 plus 21 turns out to be 46. Now let us learn the cross product. For this operation we need to use the function cross. A requirement for the cross product is that the input vectors to these functions must have a length of exactly 3 elements. This means that we cannot compute the cross product if the length or number of elements in the vectors are not equal to 3. So let's do a quick example on this. Suppose we have two matrices, that is matrix A and matrix B, which are defined like this. And then if we say cross A comma B, then it is going to compute the column-wise cross product of the two matrices. And as usual, if we want to perform the cross product based on the rows, then we can always do that by specifying additional argument with a value of 2 over here. This will compute the cross product based on the corresponding rows of the two matrices. If we change the dimensions of matrix A, let's say A equals to rank 4, which means that A is now a 4 cross 4 matrix. In the same way, we can also update the matrix B. So now, if we call the cross function, it will return an error message because, as pointed out, the requirement of 3 elements in at least one dimension is not being satisfied in this particular case. If we alternatively define A to be of size 4, 3 and B also to be of size 4, 3, and now when we call the function cross, it will be run without any error message. So in multi-dimensional matrix, first of all, they should have the same size, And secondly, A and B will be treated as collection of 3-element vectors for computing the cross product. So that was it for this particular segment. We have seen 2 widely used operations in science and engineering. We still have more math functions to cover, so do come back for that, and until then, enjoy MATLAB!